We have another problem at this screen, that is something like a flat circuit shaped like two squares, right? Squares with side length A and B respectively is in a uniform magnetic field. The induction vector of which is perpendicular to the plane, which is this, and changes accordingly to the law B naught cos omega t, Bt equals B naught cos omega t. Find the dependence of the current I in the whole circuit, on time if the resistance of unit length of wires is R dash. Neglect the inductance of the circuit. So the game is on. What does it mean by making a circuit like this? We all know flux is equal to B dot S, and if you forgot how to find the direction of area vector, I'm going to teach you right now. Area vector, direction of area vector is perpendicular normal to its plane. That's right, that's correct. So if we consider them two loops, and since these two are part of the same circuit, if I consider this a separate loop and I move through this loop in anti-clockwise direction, the area vector of this is going to be like this. Since I am traversing this loop in anti-clockwise direction, and if I am traversing this loop in anti-clockwise direction, I should traverse it in clockwise direction to maintain the continuity, to showing them that both are the same part of the same circuit. So its area vector is going to be in this direction. That means if its B dot ds, the upper square B dot ds is positive, lower the value of B dot ds for the lower part of this square will be negative, and so the total flux is going to be, why should not I remove this picture? Okay, remove it. So total flux through the circuit will be magnetic field into area, dot product of magnetic field into area, that is BA square minus BA square, and B was given something like B naught cos omega t. So if I can write here B equals B naught cos omega t, A square minus B square. Now you know how to solve this problem. You can, this is B naught, you can find minus d phi by dt. That means you need to differentiate it with respect to time and you will get nothing, but I know this will become B naught omega sine omega t, A square minus B square. So this is the EMF induced in the circuit, and if you find the EMF induced in the circuit, you can easily find the current passing through the circuit, that is simply E divided by total resistance of the circuit. Resistance per unit length was R dash perhaps, so per unit length. So the upper square, the total resistance will become 4 R dash multiplied by A, its side length was A, and in the similar manner resistance of the lower square can be written as 4 R dash B, and so you got the value of E from here. Write the value of E from here, and the current as a function of time was asked in the problem, and I hope solved the problem. Thank you very much again for watching.